So how do we use this remainder theorem to help us figure out what kind of roots we have? Do we have a root or we don't? Because remember, for it to work, you should always end up getting a zero value, right? If it's going to be a zero or a root of your polynomial term. So your remainder theorem actually is saying, if I divide my polynomial function by x minus c, and c is basically our constant term, what are we dividing by? In this example here, our c's were +3 and -3. So when we're saying, if I take a polynomial function divided by x minus c, and I get a remainder, either I should get a 0 or I should have a number left behind. So whatever my remainder will be, if I take this same c value and put it into my polynomial function, it should equal that leftover remainder. That's basically what your remainder theorem talks about. So they should be equivalent if we did division or if we just did straight substitution. When we're talking about dividing by x minus c, we are talking long division here. Okay, so when they say use the remainder theorem, they're asking you to use long division. Does anybody remember what long division looks like? It's not fun? Okay, so you do remember that part. What does long division look like? Which I think your textbook actually calls it ordinary division. Okay, trying to think, let's say we're dividing by 3. Sure. Let's use 25 because I don't want a number that goes evenly into 3. So if this was long division, where would we start?
We first look at how many times would 3 go into 2, and then obviously 3 doesn't go into 2.
Right.
So then you move to the next one, which would be 3 goes into 25 7 times.
3 goes into 25 7 times. Can we go higher?
8 times.
8 times, right?
Oh, this one.
Yeah, so you want to see what factor of 3 will get closest to 25, right? So yes, 21 would definitely go, but then I can actually go higher than that and go to 24. So 3 times 8 gives us 24, and of course we always subtract. 24 subtracted from 25 will give us 1. This is our remainder that remainder theorem is talking about. What do we call this number 8? It's got a name.
Quotient?
Yeah, that is the quotient. What is this term called?
It's the divisor?
No, this is the divisor.
Okay, so that one must be the dividend.
That is the dividend, the number or the term that is being divided. So dividend, like I said, is the term or the number that's being divided. Divisor is the number that's doing the dividing, right? The result that you get is the quotient from that division, and remainder is, like it says, remainder, whatever is left behind. These 4 terminologies, you definitely want to be at least comfortable knowing where they go, because you'll see these terms keep popping up in this section. All right, so how do we take this idea of long division and use it with a polynomial term here? So let's see, they are asking us to take the polynomial x squared minus 7x plus 9 and use the remainder to find out what p of 1 is going to be. We are not doing direct substitution here, just so that you are aware. Our polynomial x squared minus 7x plus 9, they want to know what happens. Now remember how your remainder theorem said to divide by x minus c to see what kind of remainder you get? So our x minus c in this case is going to be x minus whatever that number is. Okay, so if it's x minus 1, that means my p is 1. If it's x plus 1, that means there's a negative sign on the number itself. So this is kind of like that same thing we had done with our vertex, x minus h, you go with the opposite sign. So when the number itself is positive, you're dividing by x minus 1. If the number itself is negative, you're dividing by x plus, and then whatever that number is. Now, how will long division work in this case? So we are taking x minus 1 and dividing it into x squared minus 7x plus 9. Okay, so take your polynomial, divide it by whatever value they're giving you. Now, it's kind of the same thing that we just saw in that general example with 3 and 25. I've got x squared here, and I have just an x term here. So to be able to match this to x squared, what should I have in my quotient? Not a 2. You need an x, right? Because x times x will give us x squared. If you use a 2 here, that will give you 2x, right? Not the second power. So to get the second degree, we need to multiply by an x itself. So you are actually going to get x times x, which is x squared. And then I still need to take that minus 1, which is going to be minus 1 times x, which is going to be negative x. Every time we do long division, we always subtract. So when you are subtracting, this guy will become negative, but what happens with that negative x? Yeah, negative times negative actually makes this guy into a positive sign. So you will have negative x squared and a positive x when you change your signs. Positive x squared, negative x squared will end up canceling each other out. And you are now left with negative 7x, positive 1x, which gives us what? Negative 6x. So remember, you're only looking at the leading term of your polynomial. Since this was an x squared, this is an x. Basically, I needed one more x to cancel it out. So we multiply x times x, which gave us the x squared. We multiply x times negative 1, which is where the negative x came from. We always subtract when we're doing long division. So that means my x squared became negative, the negative x becomes positive. X squares cancel out. Negative 7 plus 1 gives us negative 6x. And then, of course, like we always do with long division, bring that plus 9 down. So I have an x here. I have a negative 6x here. So what should I have in my quotient? Yeah, negative 6. So that when I multiply, I will have x times negative 6, which is negative 6x, negative 1 times negative 6, positive 6. And then again, this is still long division. So we take a minus sign. And negative times negative will become positive. Positive times negative will become negative. Make sure you're keeping track of your negative signs. I think that's one of the only big errors I have seen in this long division is just our signs don't work and then we can't cancel stuff out. Again, I have a negative 6x, a positive 6x. These guys will cancel each other out. Positive 9, negative 6, positive 3. Very nice. This is our remainder. This is our quotient. Takes a little getting used to because, obviously if you have not done long division with polynomials, then it can take a little while to get used to. You will have one question on the exam for chapter 3 where they will ask you to use ordinary division. Remember, long division is called ordinary division here. So make sure you are not using any other method but long division to solve that. So again, practice this. If you have any questions, let me know. Now, obviously, we want to check and make sure that we did do the math correctly. This is going to work out. So this is where our checking is going to come into play. And to check, we're actually going to use substitution. So they wanted us to find p of 1 when our polynomial is x squared minus 7x plus 9, and we want to make sure we're getting that same remainder of 3. So 1 squared, of course, is 1. Negative 7 times 1 is negative 7 plus 9. What does that give you? 1 minus 7 plus 9. Should give you 3, right? Because you're doing 1 minus 7, which is negative 6. Negative 6 plus 9 will give you 3. So you should have the same answer as we got from the remainder of our long division. And that's exactly what this remainder theorem is saying, that the remainder you get when you take your p of x divided by x minus c should be the same as when I take p of c evaluated in giving us that same remainder as our answer. Questions on number 1? Anybody? Okay, so if you actually check the second page out, we will not be using ordinary division other than when they specifically ask us to. For the most part, when they ask us to solve these problems, we're actually going to be using the synthetic division to help us out. Synthetic division goes a lot faster. Do any of you remember using synthetic division? You do? Okay. What about the rest of you? Are you doing that in school right now? You're not doing synthetic? Amy, have you done that?
It's really confusing to me.
It's really confusing to you? Okay. See, now that's interesting because synthetic division is straightforward. You don't have to remember about I subtract every time I do a long division, right? You don't have to worry about signs because it's kind of built in into the synthetic division. So this is actually the same example that we have from example 1. So let's see how the synthetic division actually works out, and we can come back and compare. So let's do that. Let's do it right here on this side. So your original polynomial is again x squared minus 7x plus 9. So the way synthetic division works is you just write down the coefficients from your polynomial. If you have any terms missing, you want to make sure you put zeros in for any of those terms that are missing, but we don't have anything missing here. We've got our square term, we've got our x term, we've got our constant term. So x squared has a coefficient of 1, minus 7x has a coefficient of minus 7, and then plus 9, of course, is positive 9 by itself. They're asking us to divide by, or basically find p of 1, right? Which means you're actually dividing by the number itself. So here's the neat part. When they ask you to find p of 1, you're dividing by 1 itself. If they ask you to divide by x minus 1, then we need to change the sign. Okay, so it really depends. Are they giving you find p of 1? Are they saying divide by x minus 1? So, and you'll see an example, I think, here in the next one where they kind of go back and forth between the two terminologies. But anyway, we're finding p of 1, which means we divide by 1. Now, the way synthetic division works, this first number, do nothing. Bring it down as it is. You don't need to change it at all. It just comes down without any calculations. Then we start multiplying. So 1 times 1 is going to be 1, right? So take the 1 we brought down, multiply it by our divisor. So 1 times 1 is 1. Add, so what's negative 7 plus 1?
6.
Negative 6. Multiply again, so negative 6 times this one on the outside again. So 1 times negative 6, negative 6, right? Add, what's 9 minus 6?
3.
3, yeah. So the way synthetic division works, the last, very last number you get is always going to be the remainder. The leading terms before that, these guys make up, oh, the quotient. Now, how are they the quotient? There's no x in there, there's nothing, right? Now remember, my original polynomial was x squared. So since my original is x squared, the idea is we already have an x when we're dividing. So you always do 1 degree less than your polynomial. So if this guy is x squared, 1 degree less means this 1 actually represents 1x. So you have x from here, and then the minus 6, which is what our quotient was when we did the ordinary division or the long division. So you've got x minus 6 from the first terms, and then the remainder 3 on the last term of your synthetic division. And then of course you can still do P of 1 to do a little tiny check, and you should still get the same answer of 3 left behind. So like I said, you don't have to think about, oh, I'm doing long division, which means I need to make sure I'm subtracting my terms, right? It's just bring the first term down, multiply, 1 times 1 gives us 1, add, negative 7 plus 1 gives us negative 6, go back to multiply, which gives me negative 6, and add again, gives you the 6. So multiply and add, multiply and add. The only exception is that first number, we always bring it down. So whatever this coefficient can be, it can be 1, it can be 2, it can be negative 3, whatever that leading term is, doesn't matter, it always comes down as it is without any calculations. So, and then again, remember, if this is an x squared polynomial, your quotient will be 1 degree less than that, so that makes it an x polynomial. And I think that's what they're talking about right here. So the difference between example 1 and example 2. Example 1, they said find P of 1. Here they're saying your polynomial is being divided by x plus 2. So using synthetic division, what can we set this guy up as? Our polynomial is given to us as x cubed minus 7x plus 5, right? What term is missing from our polynomial here? The x squared. So what happens is we actually need to create a space for the missing term. So since my x squared is missing, I can actually write that as 0 x squared, and then bring the rest of your terms in. With synthetic division, we actually do that with long division also, but with synthetic division, we definitely want to make sure we have a space for the missing term, and that's where that 0 x squared will come into play. And then they're asking us to divide this by x plus 2. So that actually means they are asking us to find, in essence, they're asking us to find P of negative 2. Remember, you have to change the symbol of your, sorry, you have to change the sign for your divisor when you're doing synthetic division. If we were doing ordinary division or long division, we would just take our polynomial and divide it by x plus 2. Since we're doing synthetic division, we're only interested in the number itself, so that's going to be -2. All right, so let's set up our synthetic division here. My leading coefficient for the cube term is what? What's the coefficient for x cubed? 1. Since my x squared is missing, we need to put a 0 for that spot. Then we bring in -7 from the x term plus 5 from the constant term. They are asking us to divide by x plus 2, which means in synthetic division, we are dividing by -2. Okay, so set up your polynomial, get your divisor, and then remember the first term comes down as it is without any changes. So that's my 1 coming down. Now multiply. So -2 times 1. -2, that's going to go in our second spot. 0 plus -2. -2. Again, multiply. So what's -2 times -2? +4. -7 plus 4. -3. Multiply. -3, -2. +6. Add 11. Very good. So that means the very last term is always the remainder. And then the remaining leading terms are all going to be part of the quotient. Remember, your quotient is always 1 degree less than your polynomial. So since our polynomial was x cubed, what is this quotient going to start at? X squared. So that means the 1 is the coefficient for the x squared term. The -2 is for the x term, and -3 is the constant term. If you want to be sure that we did this calculation correctly, that our synthetic division is correct, we didn't mess up our signs or our math, let's do a quick check. So this is where we're going to find p of -2. Again, our polynomial is x to the third power -7 times x plus 5. And we want to make sure we get the same remainder based on our remainder theorem here. So -2 to the third power, what does that give us?
-8.
Yeah, -8. -7 times -2? +14. And plus 5 at the end. You can add the 5 and the 14 first and then subtract 8, or you can start from the left, make your way to the right. If you go left to right, negative by 8 plus 14 will give us 6. 6 plus 5 is 11. If you did 5 plus 14, which of course is 19, 19 minus 8 will also give you 11. So remember, the substitution part that we just did here is only for checking to make sure our math is correct. That is not our primary solving of these polynomials. So you're either going to be using long division, which is called ordinary division again in this section, or you will be using synthetic division. So make sure you're reading your instructions correctly when you do the homework, but also when these questions show up on your exam. So questions about the process for both these methods. So Amy, you said synthetic had always been a little confusing for you. How are you feeling right now?
Makes sense now.
It makes sense now? Okay. Okay, no, that's good. Anybody have questions on these two methods? Ordinary division and synthetic division. Okay. All right, let's see what this little note here is saying. So we're saying to find the value of a polynomial p of x for x equals c. Remember, you divide by x minus c, or you substitute for x as the value of c, which again, I will emphasize is only for checking our answers, not as the primary source. They're saying using long division is not an efficient way, mainly because signs can get intermingled, and obviously it takes a little bit longer to solve a long division because you have to keep going, right, till you get your remainder. But synthetic division, of course, fastens up that process, and you really don't have to worry about messing up your signs quite as much as we end up doing with the ordinary division. So let me see what you guys can do here for number 3. They're asking again to use synthetic division to find p of 3 by using synthetic division for the polynomial x to the third plus x squared minus 9. Alrighty guys, so let's take a look at what we have here. So our polynomial is given to us as x to the third plus x squared minus 9. And they're asking us to find p of 3. So we have our x to the third, we have our x squared, but you will notice between the x squared and the constant term, our x is missing. And as I was telling some of you, the order is very crucial, right? So you don't want to bring the 0x out of order. Make sure it's the third degree, the second degree, the first degree, and then the 0 degree. Also, they're asking us to find p of 3. So they didn't give us as x plus 3 or x minus 3. When they give you x plus 3 or x minus 3, that's when we end up changing the sign. So since they specifically said find p of 3, that means we're dividing by 3 itself. We don't have to worry about changing our signs in this case. So we're dividing by 3. My leading coefficient for x cubed is 1. The coefficient for x squared is also 1. Since our x term was missing, that's the 0. And then our constant term is negative 9. And for most part, you guys had that setup done, which was really nice. Bring down the first number as it is. Then we start multiplying. So 3 times 1 is 3. Add 3 and 1, of course, adds up to 4. 4 times 3 is 12. 0 plus 12, of course, is 12. And then the last one, multiply 3 times 12, which gives us, 36. And 36 minus 9, 27. Very good, which is what, as I was walking around, most of you guys had. So he is the remainder, always that last number. And then the first 3 terms will be part of the quotient. And what will that quotient be?
Plus 4x plus 12.
Yeah, so again, since my original polynomial was a third degree polynomial, 1 degree less than that, which means this starts at x squared plus 4x plus 12. So keep in mind, even though our original polynomial was missing the x term, that really makes no difference for us, because as you're writing your quotient out, again, you go in decreasing degrees, right? So we start with the x squared, then the x, and then the constant term. So that's going to be our quotient. And just as a quick check again, we can find out what p of 3 will be. with our polynomial. So that's 3 to the third power plus 3 to the second power minus 9. So, oh, that should be the third power, not the second. So what is 3 to the third power? 27, 3 squared. So plus 9 minus 9, right? These guys will just cancel each other out, leaving us behind with that remainder. So just a quick way to check and make sure our math was correct. Questions on number 3? Like I said, as I was walking around, for most of you, you did okay. There was just a couple of you got a little confused with the sign on this guy and then where we place that 0. But for most part, great job. So are we feeling okay about the synthetic division? Okay, like I said, just practice a couple times with long division to make sure you're feeling comfortable with that concept. Okay, so those were our examples for working with the remainder theorem and how we can actually solve those kind of polynomials. Now we're getting into factor theorem, which basically comes down to looking at an example. Again, we've got x squared minus x minus 6. I can actually factor this expression to find my zeros again. Products of -6 would be -3, +2, which add up to give us -1. So you actually end up getting x minus 3 and x plus 2 as your factors, which leads us into x equals 3 and x equals -2 as our zeros, or again, think about them as your x-intercepts. So both 3 and -2 will be considered zeros because when I put them back into my polynomial, I should get 0 as the answer of my function. So your factor theorem is saying the number c is a 0 of the polynomial function y equals p of x if and only if x minus c is going to be a factor. So what this theorem is saying, that if I take this number 3, put it into my polynomial and I end up getting a 0, that means that 3 is actually coming from a factor of the polynomial term itself, which is coming from x minus 3. Same thing here, if -2, when I plug it into my polynomial function and I get a 0, that means that -2 is also coming from a factor, which would be x minus -2. That's what makes it into x plus 2. So in this case, the factor theorem is specifically for the zeros of the polynomial. We are saying if any of these numbers are going to be a 0 for your polynomial, that means your polynomial can be factored into x minus whatever that number is. So looking at this example here, is x minus 1 a factor of x cubed minus 3x plus 2? So to verify that, we will use long division, but the goal, synthetic division. But the goal this time is, if it is a factor, you should get 0 remainder. If you don't get a 0 remainder, that means it's not even a factor, which means we don't even have to worry about the factor theorem anymore. So basically, anytime you're testing to see if a number is a factor, you're looking for that 0 remainder. That's basically what this little paragraph here is saying. So let's check and see what happens with number 4. So this time our polynomial is x cubed minus 3x plus 2, and they want to know if x minus 1 is a factor. And then they're saying if it is a factor, then find the others. That would be part of it. So using synthetic division, now what term am I missing here in my polynomial? x squared. So rewriting this, we should have x to the third plus 0 x squared. We're given minus 3x and plus 2. So again, make sure you're in the descending order of your powers. What will my coefficients be inside for my polynomial for the synthetic division? What coefficients do I put on the inside for my polynomial?
1 plus 0 minus 3.
Sorry?
1 plus 0.
1, 0,
And then minus 3.
Plus 2. Very good. And we're dividing by what number? Yeah, so since this was given to us as x minus 1, we do need to change the sign here because anytime it comes with x plus or minus, we change the sign, which means the 1 itself is a positive number. Remember that first number comes down as it is. Then we start multiplying. 1 times 1 is 1. 0 plus 1 is 1. And then what do we get next? 1 here. Add these guys together. Negative 2. Okay, what's next? Multiply again. 1 times negative 2 is negative 2. 2 minus 2, 0. And this is what we wanted. If we get a 0 remainder, that means 1 is a 0 of the polynomial, which also means x minus 1 is a factor of the original polynomial term. Of course, these guys here are giving us the quotient, which will be what?
X squared plus x minus 2.
Okay, x squared plus x minus 2. Everybody okay so far? Does anyone have any questions to this point? Okay, so remember, we're finding the 0 of our polynomial, which means we should get a 0 remainder. If we get a 0 remainder, 1 is a 0 for the polynomial, which in conjunction means x minus 1 is a factor of this guy. So now they're asking us to find the other factors. They're saying factor your p of x completely, which actually means just go ahead and factor this quotient part down because we've already taken care of x minus 1. So how can I factor x squared plus x minus 2? Yes?
We already know x minus 1 is one of the factors.
So that's actually going to be a third factor.
Oh, okay.
So these guys will not, I mean, it can have a repetition, but it's not this same factor from the first part.
It's x minus 1 and x plus 1.
No.
There's x, it's x plus 2.
Okay, x plus 2.
I thought it was x plus 2, x minus 1. That's how you got the 1x and the negative 2.
So yeah, you're looking for two numbers that multiply to give you negative 2 and add up to give you plus 1. So there's only one combination that really goes with 2, right? 2 and 1. Now the idea is, where do you put your signs at?
It's positive 2 and negative 1.
Very good. It is going to be positive 2 and negative 1 because when I multiply, I get negative 2, but when I add, I get positive 1. So your factors will be x plus 2, x minus 1, and then this x minus 1 is actually coming from this first part. So he is independent of us trying to factor this x squared plus x minus 2. So this will actually break down into 3 total factors. So if I look at my original polynomial term, which was x to the third minus 3x plus 2, this term actually factors into 3 individual factors. You have x plus 2, x minus 1, and x minus 1, or you can write this as x plus 2, x minus 1 squared. And if you try to FOIL all three of these, you should come back to the original p of x polynomial term. Okay, so be very careful because this is actually another example that shows up on your exam, where they'll ask you to find if this original x minus 1 or x plus 2 is a factor or not. If you find that factor, you get your zero remainder. Only take the quotient part and factor it one more time, and then basically put all three of your factors together, which gives you the complete factor for this polynomial. Questions on 4? All right, please work through your homework. If you run into any problems, come and see me. I don't know how it is outside. I was told it's not going to snow. I was told it is going to snow. Whatever conditions you guys hit, please be careful driving home. And hopefully I will see you guys on Wednesday, because apparently we're getting another storm Tuesday night. I have 10 different people telling me 10 different weather forecasts, so don't go by my word, but be careful.